Assalamu alaikum warahmatullahi shabab. Welcome to Big Bang Data Science Solutions week number 7 and session number 2. So this is the last and final session of week number 7. And in this session, we are going to learn how to actually fix the missing values, the outliers, and also the skewness of your data. So yesterday, in theory, we learned how to deal with some data quality problems. We learned how to deal with missing values. We have many options. So the first thing that we gotta do in any problem with the data, in any problem that we discovered around the data quality or the quality of the data. So number one, try to understand the source, the root cause, or the source of that problem, and trying to investigate, trying to communicate that with our team. Just find out, the more information they have, or the more investigation that you do, the better, the better way or the better you deal with the problem. So first, we need to understand what is going on with this problem. Either it's a missing value, either an outlier, either something else. Always good to understand what is going on. Is it a human error? Is it a typo? Is it a machine generated error? Is it a real value? Find out first, then make your own decision. And when you make your own decision, that might not be the final yet. So if you have a missing value, for example, and you find out those missing values were generated through a system, you could simply fix that the error in whatever database you pull the data from. You could do the same if it's a human typed error. But once you understand the source of the problem or the root, you'll be able to determine the best option to fix it. But the best option to fix it might not be the best option to fix it. So you are going to fix it, then you are going to build the model you try. Then if you are not happy at the performance of the model, you might go back to whatever preprocessing techniques that you apply to your data and try something else. Okay, so we are going to move into using the codes. Okay, so unfortunately, I have not given you yet. I have not given you yet the codes for. Sorry, I have not opened the week number 4 yet. So I promise to do that the sooner we are done with today's exercise. Okay. Where is the code? Here we go. Okay, so yes, okay. So the first thing we gotta do, as usual, let me just clear out the environment and start over. And I'm gonna pull up the data. So this is the data that we have. You got some variables in there. And most of the time, you are not going to get one file like this. You are going to get multiple files from multiple servers or maybe multiple tables. And you might need to compile them, merge them, do whatever to get the data that you are looking for. Sometimes you are going to get the data in one file like this. Sometimes there is no data. The data is somewhere. You need to get it. So there are different scenarios. It's not all. The time always. The data is not going to be always available. Sorry, guys. I need to start recording. Okay. So we got data, as you see. But the moment you look into this data, you know there is a lot of work to do. We have a lot of categorical data in there. We got a date in there, and just the surface looking, we got some missing values, got some question marks. We don't know if it's missing values or something else. We have no idea yet. So this is something that we need to investigate. Don't make a decision on them. Don't make a decision on them yet. Okay. So we are gonna read. We are gonna read the file. We are gonna import the libraries. Number one. Then we are gonna read our data. Here we go. I'm going to get the line in there. Okay. Customer name. Yeah, this is version number 3. And let me see what's going on here. So this is not the right file that we have. So we are gonna first start with what happened with my codes. Okay, guys. So just give me 2 more minutes, then we'll get started. Course computer vision. Okay. That is weird. I don't know what happened to my file. Okay, let's do this. Okay, yeah. Okay, I think I get the file. Yeah, I hate this. Yeah, it's not okay, and we should be able to see a file. Oh, it failed. Okay, folks. So my apologies. And this is 1.4. So we need to download file number 3. Okay, I think we should have the file now. There we go. Good. So yes, we are going to read import the libraries. We are going to read the detail. Again, our insurance too. Let's try. Here, no file. Oh, it's called. What is the name of the? I don't know what happened. So let's do something very quick. Pause recording.
Recording stopped.
And my apologies. So I did not know this is going to happen. So I'm going to leave this. And I'm going to go to week number 7. Download the entire week to okay. It's wrong, what's going on here? It's even this stupid file did not want to start. Okay, so okay, I got the file. Then we are going to go to week number 2, course Python. We get number 4. Then we go to week number 3, course Python. It's the same. And it's 4. Okay, and now let's we're going to try again. Okay, now we are going to try again with no, it's not there yet. 7-1. That is so weird, that is so weird. So this is 7 week 1. Come on, man, there is a code in there. Okay, let's try something else. Why there is no such file? Yes, I have a file. Okay, got the file. Okay, good. So I think I got the file, and one last thing, then we get started. نعرفش علاش ضاع لي كاع زعما كاملين ديك الكودز مشاو. And this is not funny. Anyway, it's not a big deal. Okay. Okay, can you guys see my screen, right?
Yes.
Okay, good. Okay, so let's start over. So I'll be recording the session again.
Recording in progress.
Okay. So yes, the first thing we gotta do, of course, we get the data. We have a clear understanding of the problem. We get the data. We know what to fix. So the first thing we gotta do is import our libraries, and of course we are gonna import the data. So we got the data in there. Okay. Okay, something again does not work for my. Here we go. So and we already know the the columns that we were supposed to delete. So let's take a look into the columns, and we are going to create a subset or a list of items that need to be deleted. So we are going to do to underscore delete, and it is going to be actually it's already deleted. Yeah, we deleted, but let's do this. We are going to start with the first version. Okay, and now so few of these features we know we are gonna delete them. So we are gonna delete page, a policy number, policy date, state, deductible, premium, umbrella limit. We are gonna delete zip code, hobbies, relationship gain, loss, date, incident type, collision, severity, state. Yeah, we are going to remove cities, location, hour of the day, number of car involved, property damage. So we are going to remove property damage. Oh, sorry. We are going to keep those witness person report total. The claims we are going to remove total claim, injury claim, property claim. We are going to keep their in mind. So these are the list of features that we know we're supposed to remove. We're supposed to remove age because it's highly correlated with month as a customer. Policy number is an ID. Policy being date is a date. Insured zip is hierarchy. Incident date is the date. City is the hierarchy data. Location hierarchy. Incident hours of the day. It has a minimum influence to the target variable. Total claim, injury claim, property claim is a hierarchy. So this is the list of items that we need to remove, and now we are going to remove them. We are going to do our insurance, then drop, and we are going to drop this list, which is going to be to delete accesses equal 1. Accesses equal 1 means look for a column. Accesses equal 0 means look for rows. So if I run this, I'm going to get an error because there is no such a policy number in the rows. So these are the columns. So if I do 1, then now I got them. So I got 28. So before I got 39, now I got 28 features that we are going to use. Okay, and we are going to use so we are going to use the generator. So I need to go to Arabic, this one. So I should have something for you guys on okay. No, I don't need a zip, so I'm going to simply download this to desktop. So I'm going to go to
I think we need to delete one more feature because last session we said we
27.
should have 27, not 28.
Yeah, we'll figure out.
Okay, thank you.
You're welcome. My system is acting very, very weird, honestly, this morning. I don't know why. See, it's even the data. Here we go. Cancel. So let's rename this property. Then we're going to name it 41. We're going to do yes, right. But where is it? There we go. It's corrupted file. Okay, so let's take a look. I'm gonna pause it.
Recording stopped.
Sorry, guys. Okay, so what is exactly going on with these codes? Please bear with me. Let's figure out myself. So we are going to do okay. We are going to do number 6 and session number 3. Codes Python. See, the file is not there. I'm going to drag and drop the file. 30 megabyte. Why? See, it's corrupt. Yeah, I might need to install and uninstall my Jupyter notebook. For reason it's not reading my files. Okay. Why is it doing that? Anyways, I think we should, and even it's asking me to override. I don't need to override. Just reload, please. Reload. Again. That is so stupid. This is so stupid. I lost everything I did. Okay. Yes, please bear with me. I need to. I think I have everything in another. No, I think I know what to do. باش نوقع في اش نوقع ذاك النهار اللي عقلته اللي عندي في درت اللابتوب وتكراش يعني كراش اللي عقلته عليه يعني وهذه شركه يعني I have to fix it. يعني هذا نيو لابتوب ماشي ديسكتوب هذا ديال الجيمين تقريبا في يعني بدون في يعني ماشي الشواف طلع لي تقريبا 7 المليون 7000 دولار باش قضيته وباقي فيه مشاكل. Okay, so but we are gonna fix it. It's not a big deal. So now I'm gonna go to I'm gonna go to again. Where do you need to search? So let me pull up. I'm gonna need to pull up my computer. Open. Then come on, man! Please don't do this to me. This is not the right time. There we go. See if you're gonna see it now. Okay, so I'm gonna close this, close this, close this, close this, close. And I'm gonna start over. So we are gonna do here. Okay. And I'm gonna go to okay the bandy 7 out of 10 if number 7. Here we go, number 7. Okay, so we got 7 1 course Python. شتي دابا كلشي طلع زوين. Okay, we got this codes. Here we go. Then غادي نمشي وغادي نهزو عاوتاني 7.2 codes Python. There we go. وغادي نمشي عاوتاني غادي نهزو Python 3. I think it's the same. could be the same. Now غادي نمشيو عاوتاني غادي نهزو بايثون. Yeah, I think that's all we need. Great. Okay, so not this one. No, not this one. غادي نمشيو ل 7.1 codes Python. Yeah, this is R. Okay, codes Python. I'm going to shut it off. Then this is what I want. Okay, so now we are back to business, back to work, and back to recording.
Recording in progress.
Okay, folks. So I think I got the right files now. Yeah, I got the right file. So yes, it's 27. It's already been deleted. So we are going to import the libraries again, read the data. And we got 27. We started with 39, and of course we deleted few features using the knowledge base and using the correlation analysis. Then we did some descriptive analytics, predictive analytics. Descriptive analytics in terms of statistical analysis. Then we looked into our target variable, and this is a very good number that you always need to remember. So we need to remember this value. Very important. So because this is what we are going to use as a base table. This is what we are going to use as a base table. So we got 75% of all our claims, they are legitimate, and 25% of claims are fraudulent. So we are going to need these values to use them as a base, as a base model, to use them to compare the accuracy of our models later. Okay, so a few things. Yeah, so a few things. So we need to deal with the question mark. So this is the question marks that we have. And we are going to assume that this question marks for now, but in reality we need to investigate. We are going to assume that these are the missing values. Okay, so what do you think we should do? What do you think we should do with these missing values? Everybody, anyone? No, you gotta speak. Selma, you gotta speak. Yeah, we already understand them. عرفنا بأن this is missing values. عرفنا المشكلة. عرفنا بأن it's a missing values. What do we need to do?
We should know how much we have.
Yes, now
how many missing values we have.
Yes, that is true. You need to know the influence. Number two, let's assume عرفناها. Okay, and we know we need to keep. خصنا نخليهم ونفيكسيهم. How to fix them? What would be our best option?
Replace with most frequent.
In
This is the missing value with the most frequent one.
What do we call that? So we are going to replace. With most frequency. It's called simply imputation. Imputing with mode, right? ولكن غادي تبين لكم بأن yeah, this is the best option ولكن it's wrong. Okay, let's take a look. احنا منين درنا when we did the visualization, so we looked into all this file, all the features that they have question mark. We got here the collision type. We got the policy available report, and we got property damage. كلهم عندهم question mark, and question mark. All of them have question marks. Okay, so if we were to replace this, if we were to replace replace this with the mode, what is going to happen? What is the most frequent feature? هذه وهذه and this one. For the first one, what is the most frequent feature? You can tell from the bars.
Rear collision.
Yeah, هذه هي the most frequent، ولكن إذا زدنا عليها هذه من الفوق هاي تولي في حلق. alright، هاي تمشي هذه وهنا كلها تولي خضراء. So what's going to happen? What's going to happen?
Skewness.
Not skewness.
We change the information that we have.
No, we are going to have a bias.
Bias.
يعني هذه ولات كبيرة بزاف يعني imputation is not solution. انت غادي دير imputation الى عندنا شي حاجة قليلة. if you have small missing values هذا ممكن، ولكن دابا الى عندنا هذا الحجم هذا كبير وبغينا نحول زدناها للأخرى هذه غادي تمشي. yes, it's gonna go. ولكن the other one, it is going to be too many, and we don't know for sure what is this missing values represent. وشوف هذه the most frequent is the question mark. والأخرى the most frequent is the question mark. So what do you think would be the best solution for this problem?
I think that we should split them because
no, you cannot do that. يعني تعطي النص لهنا النص الآخر لهذه.
No, I didn't mean that we split. Yes, with the two samples, or maybe the missing values we could give them a label or maybe another name and deal with them in other sites.
Yeah, that is the right approach. So we are going to rename this question mark with unknown. So that is the best approach. We cannot impute, unfortunately, because it's going to create a bias. So we are going to simply rename this with unknown, and we are going to rename this with وكان قلال يعني if we have little of them, then we can simply impute them with the mode. But since there are too many, if we were to impute, we can still impute them, but we are going to create some outliers in there or some biases in there. Any question, everybody? No, Mahdi, we cannot delete them. You cannot delete. This is almost 30%. So you cannot, if you were to delete this 30%, and this is 30%, and this is maybe 20%, you should end up deleting maybe 80% of your data. So deleting is not an option at all. So we are going to keep them and simply giving them, we'll give them a name, another label. And Mahdi, we cannot impute with the median because this is categorical data. The only option we have is the mode, is the most frequent. But we cannot do that either because there are too many. So let's take a look now. As you see, the question mark is 18% for the collision type. The question mark for the second one is 34%, is almost the highest, and the question mark for the second one is 36%. So this is 18, 35, 34, 35, 36. There's too many. We cannot delete them. We cannot impute them with the mode, unfortunately. So we got to keep them and give them a label. And this is where we are going to use replace. So our insurance, please replace anything that is a question mark with an unknown. So let's do this. And if I were to run this again, this snippet of code again, I'm going to have unknown, unknown, unknown. So we dealt with the question mark. So we dealt with hierarchy. I'm sorry, with features. We removed some features using knowledge base. We removed some features using the correlation analysis, and now we dealt with missing values using the relabeling. Okay, so now what we gotta do is we are gonna look into we are gonna transform the categorical data to numerical data. So we already agreed in one of the sessions that this categorical data that we have here, they are not ordinal data. They are not ordinal data. So that simply means we cannot use ordinal transformation. We cannot use mapping, replace male with 1, female with 2, or vice versa. We cannot do that because this categorical data that we have is nominal, not ordinal data. So for the nominal, there are many options that you could use, but one of the let me start over, please. So one of the options that we have is simply either to use one hot encoding if you are using the scikit-learn, or you could use the dummy variable if you want to use the pandas. So it's totally up to you, but I'm going to use the dummy variable. And the dummy variable, if you guys remember, the process is to use it with k minus 1. Okay, so first of all, let's figure out how many categorical data that we have. So for policy state, we are going to have 2. We got 2, we got 1, we got 6, we got 13, 19, and we got 30 and 38, and we got 30. So let's take a look into the list. So this is all the list of features that we need to transform into categorical data. List of categorical features that need to be transformed into numerical data. Okay, so we could do a replacement. So replace male with 1, female with 2. And we learned what is the problem with the replacement. And I'm going to test your knowledge again, see if you guys remember what we covered. Why do you think we cannot do the mapping?
Discrimination.
No, that is there is an ethical, yes, that is exactly what is happening, but the system does not know discrimination.
We change from categorical to ordinal.
Yes, that's the answer. So we have the category. No, brother, no, that is not the question. That isn't the answer. You are very close. You are very close. Just chance few things in your statements, then you should have it correct. So what is this? Male, female.
We transform not minute to original value.
Yes, that is. So we have nominal. We have nominal categorical data, and we are transforming to ordinal. 1 and 2, there is an order in there. Male and female, there is no order. And we got single vehicle collision, vehicle theft, etc. So this is not ordinal, and we could simply transform them very quick. And we got here the 6, we got 0 and 1, but that is not. This is not what. This is not what we should do. Okay, so we got insert 6010101, but this is not. We got the incident type 1323, but this is not. Why is that? Because these are actually we are doing transformation incorrect. So what we gotta do now? We are going to do. We could do label encoding. We could do label binarizer encoding. We could do one hot encoding, but I am going to do the dummy variables. So this is a template. You could use it for your projects. It's already preset for you. Just run it and change the data, change the variables, and should be able to use it. So I'm going to skip all those techniques, and I'm going to jump straight to a dummy variable. So we are going to make a copy of our data. So we made a copy of the original data. Let's take a look into what we have. So we got 27 features. Let's take a look into the statistical analysis of the object features. So this is what we have. And now we are going to determine, what feature are actually categorical. So this is all the categorical features. And remember, we got 27 features. Got 27 features so far. And out of these 27 features, we got a couple of features that they are categorical, and we are going to use the dummy variables techniques. Okay, so we are going to transform anything in this our insurance copy, which is the second version of the data. We are going to transform anything that is not number. So we created a variable called toDummy, and this variable holds any elements from our data that is not, which its type is not numeric. And we are going to use get dummies. This is a pandas library. Then we are going to apply this get dummies for our copies. And we are going to change not everything. We are going to change only whatever has been selected into this variable. It simply means all the categorical data. And we are going to do drop first, means k-1. We are going to drop the first element. So for example, in policy states, we got 3. So we are going to create 3 columns, but we are going to drop 1, the first. Policy CSL, we got 3. We are going to create 3 columns for this, but we are going to drop 1. We are going to drop 1 here. We are going to drop 1 in every single, for every single feature. Why do we need to drop? Is because those, if we don't, then we are going to have some duplicate information in our data. Here we go. Now, so we done. So as you see, our data all is numeric. Our data is all numeric. So let me ask you a question. What do you think should be our, so now we got 133. We started with 39 features. This is the raw data. We got 39 features. Then version 1 we got 27, and version 2 we got 133. Okay, so this is the most ready so far. This is the most ready version yet. But of course, we got 133. So if we were to look into this data, what do you think we should do? There are two things, at least there are two things that we need to do. Two steps that we need to take. What are they? Anyone, please?
We have to delete the features with the high number of units.
We don't have any Unix anymore.
So I didn't understand the question. Is it do you mean by this question what is the problem with the version number 3?
So now we got version. Now this is version number 3. Version number 1 is the raw data. This is the data that the company gave you, and it has 39 features. It has a lot of problems. It's missing values. So we were able to reduce the number from 39 to 27 using knowledge base and also using the correlation analysis, right? So we got 27, but this 27 we got maybe 14 features. They were categorical data. So when we transform this categorical data into numeric, we ended up having 133 features. So
And actually, I think so. We increased the dimensionality of our problem.
yes, the question is, what do we need to do?
We need to apply some technique of dimensionality reduction.
So we need to reduce what? The dimensionality. Okay, we need to reduce the dimensionality again. Number 1. Number 2, Mahdi, I think you really need Ayus Abdullah, please mute yourself. So let me mute you guys and unmute yourself if needed. We need to reduce the dimensionality, number 1. Number 2, what do you think we should do to this data? Look, we got some 50, 500,000, we got 0, we got 2, we got 0, 1, we got 23,000.
The big numbers and low numbers.
So
And,
what do we call that? What do you think we need to, and why?
Normalize.
we should,
We could normalize, we could simply, we are going to scale.
scaling, maybe scaling
Why?
so we can treat the numbers with the same
The same what?
the same level.
Sarti Jihad, you are, if you are the person talking,
Yes,
yes, you are in the right direction, brother.
because big numbers are treated with machine learning with a different way. If we have low numbers,
Yes, but why? What is going to be the problem?
we will give more importance for the big numbers.
Yes, then what is going to be the problem?
The data will be skewed to the right, sir.
Say again?
The skewness problem.
No. Yeah, Jihad, you are in the right direction. Please continue. Sufyan, yeah, Sufyan, yes, Sufyan, you got it right, because it's going to be there's going to be a bias.
Yes.
How the bias is going to happen is because the machine learning is going to try to think this is very important. So it's going to focus on these high values. It's going to learn from these high values, but it's going to ignore, mathematically speaking, it's going to ignore these low values. It's going to think this is not important. So it's not going to learn. The model is not going to use any of these low features to learn. And these features could have a lot of great information to make a decision. So we need to reduce the dimensionality, and also we need to scale. Why do we need to scale? Is because the machine learning is nothing but a mathematical equation, and it deals with numbers. $1 is better, is less than $2. $5 is greater than $1. إلا عطيتك خمسة دراهم وعطيتك 10 دراهم راه ماشي كيف بالطبع يتهز مني 10 دراهم ما غاش تهز مني 5 دراهم. That's very simple. This is machine learning. If you give high values, high numbers, it's going to concentrate, try to learn from the high numbers, it's going to ignore the low numbers, and it's going to create a bias. So our job is to minimize the bias as much as we can. Okay, Deba, what do we need? What do we need to do with to reduce the dimensionality? What did we use in the past?
Correlation.
We did correlation analysis. What else? What did we do in the past to reduce the dimensionality? So we got 39 features, then we reduced the dimensionality to 27. What did we use? I don't think you guys are doing your homework. I don't think you are putting effort in this program.
First, we use prior knowledge. Then
yes, here we go. We use the prior knowledge. We use the prior knowledge and the correlation. Okay, what do we think we should do now? This is what we used in the past. Then what do you think we should do now to reduce this 133 one more time? Can we use correlation?
Yeah.
Yes or no?
Yes.
Anyone?
Yes, we could use just the correlation.
Why?
Because the prior knowledge are already done on. So we had to see the correlation between values that we have.
What if I tell you we cannot use correlation at all? We cannot. Why? Why we cannot use correlation at all?
We already used it.
Doesn't matter. You could always use it, but in our case we cannot use it. Why? Can anyone remind us what are the conditions of a very good correlation analysis? There are 4 conditions. Number 1 is pairs. Okay, if you got 1,000 in this line, we need to have 1,000 in this line. Number 2, we got to have numeric data. Number 3, I think we have linear data. And number 4, which is very important, we got to have a real numbers. Real. So is this real numbers? 0, 1, 0, 1, 0, 0. Are these real numbers?
They are not. What do you know?
They are transformed numbers, right? Do you guys
Yes.
agree?
Yes.
So we
Yes,
cannot
sir.
use, I mean, we still can use correlation analysis. Yes, we can still use correlation analysis, but the numbers that you are going to get are not correct. These numbers are not correct. All of these numbers, they are not, they don't tell the truth. They do not tell the truth because we are using correlation on a number that been transformed, not the real numbers. We used it the first time because at the time we still have our value, our original values. So when we first used it, we used it in these values because this is our original, not been transformed yet. But now we don't have male anymore. We got zeros and ones, and these zeros and ones, they are not real. They are representing male or female. So we cannot use correlation anymore because we don't meet the condition. And also we cannot use prior knowledge because it's done. So we got to use something else. And we could use machine learning, we could use other techniques, but we cannot use correlation analysis, and we cannot use, if we don't have transformation, if we don't have transformed information, we can still use the correlation analysis. Folks, any question please? يعني شباب مفهومة يعني مفهوم القصة.
I heard the other techniques that we can use.
Yes. Yeah, there are many. Just name one. We could use machine learning, the importance features of the scikit-learn. We could use that one. That one was the best.
Okay, thank you.
Yeah, we could use. There are other techniques that I used in the past, but there are many features. Many methods that we could use. Okay, but we cannot use correlation analysis anymore because now we don't have real values. Please remember that you still can use it. We still can use it. Correlation still gonna work if we were to use it, but the values, they are not representing the reality. So that is a bias in there. If you were to use it, it's a bias. There is a bias. So if you were to remove any features out of this, it is going to be a bias. And of course, that is why we're trying to fight. Okay, that's why we're trying to fight. So we cannot. So if you were to remove this one, it has high value, then definitely you are most likely you are going to do something stupid. Okay. Now, okay, correlation. We could do the correlation analysis. There we go. Visualizing the correlation. So you got a lot of correlation in there. And now we are going to save as version number 3. We got to save as version number 3. In this version, what do we have? We got 133 features. So version number 4 is now we need to apply dimensionality reduction one more time, and also we need to scale. And the version number 4 is going to be the best. It is going to be the method. Version number 4 is going to be the data set that we are going to use for machine learning, which is going to be next week. Okay. So it's going to be version number 4. So what is version number 2? Is the raw data. We reduce the sum of dimensionalities from raw data using knowledge base and using the correlation analysis. Version number 3, we dealt with the missing values, outliers, very quick, duplicates, which we didn't cover unfortunately, and we transformed the categorical to numeric. And now we got version number 4, which is a version where we are going to remove. Now we got 133 features. Then we need to remove some of the features using some scientific method, and we are going to scale our data, and then we are going to move into modeling next week. Okay, so let's try to grab. This is version number 4, and now I think this is the file. Let me see. Yeah, I think we. This is 3. And now we need to read. Okay, now we. What time is it? Yeah, so that's what we are going to do next week. Next week, inshallah, we are going to reduce this dimensionality one more time. Let me go through this. So we are going to reduce this dimensionality one more time. Of course, we are going to use some scientific method, and we are going to reduce also. We are going to reduce the dimensionality, and we are going to scale the data. And after that, we are going to learn our first model. We are going to start with a decision tree. So, any questions, concerns, please?
Yes, sir.
Yes.
What is the limit of the number of features that we can have in our?
There is no. There is.
no
I mean, there is not. There is. It's not. There is no limit. The rule of thumb. I will handle. What do you call it in Arabic? القانون الذهبي. A rule of thumb, or the golden rule. يعني, this is your data. This is the columns. This is the rows. The best data that you could learn a model out of it is the data with limited columns and unlimited rows. Unlimited rows. يعني you have few, you got here as many as possible. Okay, as many as possible. So out of 133, how many we are going to keep, we don't know yet. But we are going to use, we probably could stick with somewhere between 20 and 40. Somewhere from 20 and 40 should be fine. We could do that. Yes, you could do that. But again, it's totally up to you. Okay, folks, any questions, concerns, please? Any question or concern or a doubt, please?
So for the next dimensionality reduction, the method is using machine learning.
We are going to use machine learning, yes.
Okay, thank you.
We are going to use machine learning, or there is one method I'm using for my project now with Yeah, this is a project. Let me pull it up for you. Just give me a second, then I'll show you what I am using. Yeah, this is one project I'm actually working on today. This is for a client, and this is what I'm using. I'm using a method. It's MLX extend library. It's called sequential feature selector. It's an MLX extend library. So it's not a scikit-learn library. So I'm using this package. Okay, but we'll figure out what to use. But this is the one that I've been using. Of course, we could use machine learning. We could use some scikit-learn. You could use scikit-learn, but or you could use ML extend. We'll try both of them. Just remind me on next week to try both of them to see which one works better. Yes, if you have ordinal data, yeah, we could simply apply mapping, and you should be good to go. PCA, principal component analysis, it's a good method, but you are going to lose a lot of information, and you are not going to be able to track what is what. So your PCA, you are going to eliminate, you are going to limit the numbers to only two features, and those features simply they are representing the variables at the most. So you are going to lose a lot of information. So other questions, please. Other questions, concerns, please. What is about MR? What is MR? ما عمرني سمعت عليه. I never heard about it, or maybe you have it in
So it's the maximum relevance, minimum redundancy algorithm.
I never heard about it, honestly. Yeah, this is good to know because I'm learning something from you guys. Okay, yeah, so this is something I learned today. Let me go through this, see if anything that we can use. Okay, thank you for sharing that, Maddie. Thank you. Minimum redundancy, maximum redundancy. Okay, we'll figure out. Given machine more tasks, selecting the minimum. Okay, pp install. Yeah, I'll try it on my project. Okay, from scikit-learn. Yeah, I'll figure out. I'll figure out how to do it, and definitely we can. Now we apply correlation analysis before transformation. Once you transform your categorical data into numerical data, you cannot. I mean, you cannot trust your correlation analysis anymore, because you are now applying correlation on transformed numbers, not real numbers. You still are going to get a correlation, but that correlation values that they do not represent the reality, and there is a bias. So you cannot. We're trying as data scientists. Our job is to minimize bias as much as we can. Okay, folks. Other questions, please?
Sir,
Yes.
if we have a lot of missing values on numerical data,
Then you need to impute with a lot of missing values. You need to impute those missing values using the mean or the median or the distribution or other techniques. You cannot delete them because you said a lot, right?
yes.
And you could, if you have missing values, and within those missing values and those columns you have some outliers, then we are going to use the median. If you don't have outliers, then we are going to use the mean, imputation with the mean. And this is what exactly I'm doing for this project. No. So replacing some features with a noun, and this one replacing this feature with the mean. This is why I do for this is a real project. Okay. Okay, folks, that's it for today. I'll see you guys next Saturday, inshallah. Until then, you guys have a great weekend, and assalamu alaikum wa rahmatullahi ta'ala wa barakatuh. إلى اللقاء.
Thank you, teacher.
Yeah.
Recording stopped.
Thank you. See you next week. Bye.
Thank you.